morning, everybody. Today we are going to configure a router. We're going to be setting up some layer 3 interfaces on a virtual Cisco router. We are going to send some traffic through there to test it, and we're going to take a look at the routing table. Let's get to it. So we're picking up where we left off. We're just jumping into the configuration. And as always, Tiny Brian. Okay, let's see what we got here. Here's just diagram from last time. We had some imaginary router, a couple of switches, each with their own broadcast domain, and some clients on each side. And one interface over here is set up in the 10.0.10.0 network. Other interface on the router in 10.0.20.0 network. And dramatic pause. I made one. This is still pretend, but a little less pretend than Paint's given us. Let's see if I can just arrange things. There we go. So here's what I got. This R1 in GNS3 is an older, but still valid, Cisco router. And then a couple of OS 10 switches. These could totally route as well, but we're not worrying about that. And what we've got set up here is that R1 has these two interfaces currently with no IP addresses, no actual routed interfaces yet, but they're cabled up to these couple of switches with our clients down below. I'm going to pull up the command line here. Actually, you know what? Before we do the command line, quick look at what this pretend router is. So this is an old Cisco 7200 small chassis router. And that's what we've got a pretend one of here. And we're going to be using the socket number 2, the module number 2, 0, 1, and 2. So 2 is the third. And it's going to actually look quite a bit like this random picture I found online with a handful of gigabit Ethernet ports in that number 2 slot. And one of these is going to have an IP address on it. Another is going to have an IP address on it. And that's going to be our routed interfaces. Okay, now the command line. Whoop, here we go. And this is our Cisco C7200, currently with nothing on there. Show IP route. Nothing on my sleeve. No IP addresses on there. No networks it's aware of. Okay, I've did things a little bit different here than I had in my drawing. Go big there. PC1 is the only thing currently on that switch number 1, and PC2 and 3 are over on switch number 2. And basically what this means is that they should not be able to talk across all three of them, right? 1 can't talk to 2 and 3, but we should see that 2 and 3 can talk to each other because they're on the same switch, same broadcast domain. So I'm going to go over to PC number 2 here, and I've already done a show IP. It has an address on here of 10.0.20.100/24 and gateway of 10.0.21. PC number 3 over there is 10.0.20.101/24 and gateway of 10.0.20.1. I'm just going to ping from here back to PC number 2. Ping 10.0.20.100. It's working. Love it. Now I'm going to try and ping back over to PC1. Let me pull that one up. It's got an address of 10.0.10.100. And it should not work. None. Depending on the operating system, when you run a ping, you might see a bunch of failures in there. It might just come back and be like, nothing happened, man. That's what we got going here. Nothing happened. So what we would do next if we were troubleshooting, we'd be like, oh, well, I can ping other devices in my network, but not other networks. Can I ping my default gateway? Ping, in this case, 10.0.21. None happened. Yeah, right. We know we haven't gone and set the darn thing up. So now I'm going to get into the command line of this R1 over here. Boop. Okay, we're back over here on our R1, and we've already got our show IP route. Nothing there, right? And so now let's go check on those ports. Show IP and status for most, but on this one, stats, I think? Oh, come on, Brian. Show interface. Stats is what I'm looking for at the moment. All right, and I can see here I've got those different modules in this router. Pull up our pretty picture again. Yep. Can I stick that over on the right? Yeah, that'll do. Okay, And we could see in this one, interface 0/0 is disabled. Interface 1/0 is disabled, but 2/0 and 2/1, well, those are set up over here, and that's in this module number 2. Something's plugged into them, they're working. We want to go configure those now. The reason I did this show interface stats on a lot of routers and switches, show interface status, I want it to list off the ports that are on the darn thing and tell me the name of them, because a lot of different routers and switches will call them by different names. Now we're going to head over to config mode. Config T, yeah. Conf T if you don't like typing, or config terminal. And now we'll go to those ports. Interface, and we saw here it's Ethernet 2/0, Ethernet 2/1, so lower first, just for kicks, 2/0. I tabbed it out, but ETH would have been fine. And now I'm going to go put an IP address on there. Now, last time we said it would almost certainly be something very much like conf T, interface ETH 0, or whatever, and then IP address and put it in. Now, I gave you this /24 last time. We're still going into much detail there, but this Cisco is going to make us type out the dotted decimal. 255.255.255.0 would be the equivalent of that. IP address. What we're we doing? Sorry, go to our diagram. Yeah, okay, for this side, it's going to be 10.0.10.1. And so IP address 10.0.10.1 and 255.255.255.0. Press enter. Yeah. And then I could jump straight to the other port, but I'm going to exit out of there and then go back into the other port. Interface ETH 2/1. That should be our other port. And now I'm going to give it 10.0.20.1. 255.255.255.0. Awesome. And okay. I'm tempted to go run some show commands on here, but before we even do, let's jump into it. Let's get the good stuff. Let's make sure it's working. PC3, that's where we were before, should be able to ping, where'd I put you? 10.100 now. There it is. There it is. Yes! And so PC3 says, my address is 10.0.20.101, and user is trying to get me to ping 10.0.10.100. And so that 10.100, it'll say, oh, well, I'm /24, 255, First 3 octets have to match up, 3 dotted numbers. And I'm 10.0.20, trying to get to 10.0.10. Got to go to my default gateway. So it does, and sends it over. When the response comes back from PC1, it's going to do the same thing, but in reverse to get it back to us. Okay. Perfect. So now we got communication between them. I'm going to head over to R1 again. Show IP route. And this is going to give us our IPv4 routing table. And now we got something in here. We didn't before. Now we have 10.0.10.0 is directly connected to Ethernet 2/0. 10.0.20.0 is directly connected to 2/1. Notice this is the network address. 20.0 is not what I typed. I typed 20.1. 10.0 is not what I typed. I typed 10.1. This is the network address saying that whole network is there, not just the individual address. Now, if I did something a little different, I haven't showed you yet, show IP interface. Oh, hang on. Show IP interface brief is going to be a little better for our purposes. Cool. Show IP interface brief works on most switch and router operating systems. And on Cisco, that's going to show you all of your ports that could have a layer 3 interface, a routed interface, tell you if they're working or not, and tell you the actual IP address that's on there. So yeah, Ethernet 2/0 has the address 10.0.10.1. And that's why it's got that network. 2/1 has 10.0.20.1, and that's why that network's the routing table. Awesome. Okay. And then as far as these switches are concerned, right now they're set up for only passing layer 2 traffic. I didn't do anything but configure spanning tree on the access ports. That's just a good habit. They're just single broadcast domains right now. And on R1, it's just these 2 different layer 3 interfaces. If we had a 3rd or 4th port on there, we would not be able to have them in either of these 2 networks. On a router, every port, generally speaking, needs to be in its own network. Or certainly if you put an IP address on a port, That's the only place that network can exist on that router. But you hook a switch up to it, and now I could have 50 different computers maybe plugged into that switch, all in the same network. All that can talk to each other when they need to, no problem, and get to their router when they need to talk to someone in another network. Yes. Okay, are we missing anything here? The ARP. Just to tie it in there as well, on our routing device, we are going to have ARP entries for those hosts, 10.0.10.100. And there's its MAC. 10.0.20.101, and there's its MAC. Now, we don't have 20.100 yet, because it hasn't said anything yet. If I went over to 20.100 and ping, 10.0.20.1, it's default gateway. Getting a response now, right? And if I come back over to R1, show IP ARP again, and there's 20.100, right? Because to respond, the router would have had to ARP and find out the answer. Awesome. And just to nail down the last little thing, if I go over to those switches that are layer 2 only and do a show IP ARP, different operating system, but I believe the command's the same. Yeah, nothing there. Because they don't need to have anybody's ARP, but MAC address. They've got MAC addresses for devices on their own network. And for this one, it's it's just what's been learned for the router on its 1/1 here, and the host on its 1/9. Not going to learn any MACs from devices on the other side of the router, because it's a different broadcast domain. Yeah! Okay, so just a little quick one today to follow up on last time and show you those commands. Y'all, I'm enjoying this, and I hope you are too. Like, if you're liking it, subscribe if you want more, and please, please, I'm just getting into this thing, so if you got something you want to know more about, maybe you're studying for a test, and there's something that's that you're a little concerned about that you want to get to talk about, maybe something in here sparked your interest, let me know. You rock, y'all. See you next time. So, what are you doing?
I'm hacking the router. Perhaps the secret files are still within.
Didn't we just learn about how, the packets are teeny tiny and they're barely in the router for like a bajillionth of a second?
Ah, crap.